Okay, this is the work for page 4, guys. So you should have gotten 0, 2, and 3, 0. We plotted the points. And then when we tested 0, 0, it did satisfy, so we wanted to make sure to shade where that test point was included. So we would have shaded below on that one. Bridget, did you have it right? Okay. Does anybody need this one up there to check theirs? Okay, page 5, guys. Quiet up, please. A little loud. Page 5, guys, you should have gotten 0 and -2 as your y-intercept, and then 8, 0. And so your graph with a solid line would be there. When we tested 0, 0, it did not satisfy. So we would shade below the line here because that 0, 0 is not included. Okay? Questions so far? Does anybody need to go back to any other page before we go on? Because we're about to finish the last 3 examples, which are not really special cases, but they're a little bit different.
Wait, what was the page 4 one?
Page 4, it should look like that.
Wait, can you go to page 5 really quick?
Yes, ma'am. Page 5. Can you see that okay or no? Or do I need to move it down?
Okay, thank you.
You good? Okay. So, if you look at page 6 now, this is going to be done just a little bit different. So let me get over to page 6. Part of this is, it's the same concept, but we've got to look at it just slightly different. According to your steps, the ones that we got from that little green, little foldable, first step is equation must be in ax plus byc. Is that in ax plus byc? No. Now, from 7-1, we learned that this format is only when we have a c equal to 0. And we can rearrange standard form so that y equals some value x. Okay? One of the qualities from this type of expression or inequality is that it's going to automatically pass through the origin. Okay, so for example, if x is equal to 0, when I plug that in, what is y going to be? It's going to be 0, right? That's why our 2 points, or our x and y intercept, is already 0. 0. Okay, so can we technically use this as a test point later on? No, because that's going to be a part of my line. So to graph this, we already have 1 point. To graph this, we need to pick another point. So another x value. Pick another x value. Okay, x equals 2. I've already heard Kyla say it. So this is not a testing right now. This is me just getting another point so that I can plot it correctly. So let's plug this in. Y equals 3x. So plug in 2. Okay. What is my y value going to be? 6. And so let's create an ordered pair, 2, 6. And now I have 2 points that I can plot. Once again, I know we're still working with inequalities, but when we get our 2 points, go ahead and turn it into an equation so you don't have to worry about the sign. Now, you're going to go down to your graph, and I forgot on this one to draw the x and y axis, so please do that on your own. Okay. I forgot to plot those on there. And then go ahead and plot your 2 points. Plot your 2 points. 0, 0. It's here in the middle. And then 2, 6. We're going to go over on the x-axis 2 and then up 6. And then now we need to ask ourselves, is this going to be a solid or dashed line? So based on the inequality, what do we have? We have a solid line. Very good. Oops, solid line. I didn't mean to connect those words. Okay, so take your straight edge, make a solid line. That portion you can go ahead and do before you shade. Okay, and so right now you should have this for your inequality. Now we're not done yet, because what is step 4? We need to decide which side we're going to shade. Now, before now, all we've done is tested 0, 0, but we already decided we can't test 0, 0 because it's a part of our line. So you need to pick somewhere in your region, or in your graph, another point. And so I think, who said it? 1, 1? Sammy? So what we're going to do is we're going to test this point here. Okay? So my test point is 1, 1. We're going to plug this back into our inequality, which was y is less than 3x. So we're going to plug in 1 is less than 3 times 1. And we're going to simplify this. 1 is less than or equal to 3. And ask ourselves, is that a true statement? Is 1 less than 3? So if it is, do we shade the side that the point is on, or that the point is not on? Is on. So we're going to shade this side right here. Well, no. So let's just do one as an example. Let's say that we wanted to test this right here, this point here, okay, which is what? 1, 2, 3, negative 4, comma 3. Let's say that you had chosen that point to pick. You're still going to plug it into your inequality, okay? 3 is less than 3 times negative 4. 3 is less than or equal to negative 12. And you're going to ask yourself, is 3 less than negative 12? No, right? And so if that was our original test point, we would still know that this is the side we shade. So if 0, 0 is not a point that you can test, it doesn't matter which side or area or quadrant that you choose, you should still get the same result on deciding which part to shade. Okay, this one did not satisfy, so we shaded the other side of the line. This one was included, so that's why we shaded that side. Yeah. Very, very good. Does that make sense? Does anybody need me to zoom out and get this? We have 2 more examples to do, so I'd like you to wait. Okay, last 2 examples. These are examples with vertical and horizontal lines. Okay. Now, on page 7, this is x is greater than 2. Last class, or not last class, but 2 classes ago, we did a little foldable Hoy and Vux. Okay. Now, x is greater than 2. We can treat this like what type of graph? Let's graph it. Let's graph x equals 2. Okay? Now, how do we remember if it's a horizontal or vertical line? Well, x equals 2, we're going to think of Vux. The v makes us think that it is a vertical line. Okay, it's vertical. So, the easy part about this is we're going to go to our x-axis, go over to 2. However, we still need to ask ourselves, is this going to be a solid or dashed line? So we're going to draw a solid line. Very good. And it's going to be vertical. And hopefully you remember what vertical is. It is up and down. You laugh, but every year I have students that mix it up. Okay. I will tell you, people mix it up. It's common. Okay. Okay, now are we done with this yet? Are we done with this inequality? No, because we still need to shade which side. Now, with these, there's not really a test point that you can do, but what you can ask yourself is what values of x on the graph, and I'm just writing this out because this is notes and this is what you need to think of in your head. You don't have to do this in your homework. But what values of x on the graph will be greater than 2? Okay, would I shade to the right over here? Do these values represent greater than 2, or do these values over here, the left? Which one would you do? On the number line, I'm going to shade everything to the right, because everything to the right of this line represents values that are greater than 2. Very good. No, because this is a vertical graph or vertical line. It has undefined slope, and so there would be no test point that you could do because there's not a an x and a y coordinate pair, if that makes sense. But anything to the right of this would represent satisfying the equation. Okay, it represents values greater than x. Let's do the same thing for page 8. Okay, we've got y is less than, this is the last example, and then you'll have the rest of class to finish setting up your notebook. Okay, we're going to graph y equals -4, and go ahead and look, what kind of line am I going to have? A dashed. Okay, so let's go down to our graph and graph this. We're going to go to -4 on our y-axis. And for y equals a number, we think of HOI. And that h tells us that our line is going to be what? Horizontal. Okay, so take your straight edge down to -4. Don't make a solid line because we've already determined this is going to be dashed. Okay, now we need to decide, we need to go back up to our inequality and say, okay, what part do we shade? Now, what values of y would represent less than -4? Do we shade above? Are those values less than -4, or do we shade below the line? Below the line. Okay, guys, we are not done with notes. You are very, very talkative, so please quiet up. Yes.